Hello everyone and welcome back to another video. Today we are going to do some gameplay of Freecodecamp, and we are going to do the object-oriented programming course thingy from the JavaScript algorithm, the data structures. So we are going to do what every programmer loves the most, and that is obviously object-oriented programming. So let's get into this gameplay. We need to make a dog object. So this is pretty easy. We just need to kind of copy this. So we'll do name, right? We're gonna say name. So what is the best name for a dog? Dog. And what is the best name? What are the legs number? It's obviously 3 for a dog. You also want to put this. And I think that's it. That's everything. So we can run the test, and there you go. Right, now we are going to do something way more complicated, and that is actually output the name. So we got that name spot over here. It kinda changed it, and it also added a lag, but that's okay. So what you want to do here is you want to console log, and you want to do dog that name, of course. So now you'll see it auto spot. Oh, you also need to do this for the number of legs. So we can do this simply. Just add this in here, and there you go. It works just fine. Let's go to the next one. Alright, let's create a method on the object. So objects have a special type of property called the method. Okay, I guess this thing. Methods are properties that are functions. This adds different behavior to an object. Here is the example of the method. So as you can see in this example, it has this method. It's called sayName, and what this basically does, it's a function, and it just returns something. Obviously, you can probably make this more complicated. So this method should understand this dog has 4 legs. So what we want to do is to make this. It's already made it here, so to say legs, make it a function, of course, so it knows it's a method. And in this function, what we want is add this, and now we need to return the name. No, how do this dog? Okay, this dog has. Alright, and now we need to do this little plus. I think there's a better way to do it, but I kind of forgot it. So we need dog that num legs like this, right? And okay, we also need that dot at the end, so we'll do something like this. And yeah, so let's try this. Should return the given string. Let's see what it does. I'll just do console.log dog say legs, so we can see where we have the issue. Made. Oh, of course, you have to also give it a thing. So it says this dog has 4, which is pretty obvious why it isn't working. We also need to add we can do this in a single thing, legs, and we also want a little space here. And there we go, it worked. So yeah, small issue, but now it works. So let's see, make code more usable with this keyword. So the last challenge introduced a challenge. You need hydration. Right, so the last challenge introduced a method to the duck object. It uses duck.name and to survive the name property with the return statement. Makes sense, makes sense. Alright, I see. So what this basically is, when you are in an object, you can say this instead of just naming it. So we can just do this. Oh, oops, this. That num legs, and this should work. Yep, there you go. So let's just explain this a bit. When you are inside an object, you can just say this, and it will refresh the dog in here. So this, it's equal to the object name. So if you name this like cat, right, and we also name this cat, it's not going to work, but it's still going to do the thing. So let's just do um, how is it, like cat, say legs, and just do this, and it will also output it. So this works now, no matter what the name is. Can you control Z? Yeah. And there we go. So let's go into the next challenge. Now we need to use a constructor. So constructors are functions that create new objects. I didn't do this, by the way. They define properties and behaviors that will belong to the new object. Think of them as a blueprint. So if you use the Unity, you know, I assume this is kind of like a prefab in there, where you know you can have like a prefab for a bullet and it has some properties in it, stuff like that. So here is an example of a constructor. So we can just make one real quick. I just like copying this and you know just changing what it needs to change. So let's just change this to something more accurate. The color of a bird, you know, dogs aren't blue, they're obviously green. And let's put our name. What the dog doing? There we go. So now we should run the test and it absolutely works. Alright, we are going to now use the constructor to create objects. So this is the function that we created, like the constructor thingy, and now we actually like use it and create a new object. So this is, as I said, imagine this as a prefab like on Unity. You didn't yet make it, but you now are going to like spawn it. It's kind of like saying in the code like spawn the prefab that you made in Unity. We made this prefab and now we spawn it, right? So we are going to do we need to make a use a dog to create a new scene assigned to verb. Okay, so we need to make it hound and we are going to just do new dog, and I think this should work. So let's click, and yes, if you do a console log dog, does this even work? I'm not sure. Okay. Alright, so you cannot really, oh, you can do dog that color, I think. Whatever. Even oh well, who cares? So bluebird that name. Oh, you need to do hound, of course. Oops. Yep, and there you go. I forgot you need, this is not this is a prefab, it's not the object, so you cannot call it. As you see, I did a mistake. I put dog, which is how this prefab is called, but we actually need a hound because this is the variable, right? Next. So now we are going to do extend constructors to receive arguments. Alright, however, notice that all birds are creating this bird automated. All birds are blue in color and have two legs. What if you want the birds with different values? Okay, yeah, makes sense. Maybe you want like you don't want a single bird, right? You want it's possible to change the properties, but there'll be a lot of work, yeah. So you could do something like this, like in the previous example. We could have just done like also assign new variables to it, or like not variables, how is it called, you know, like the properties, yeah, properties in it. You can change them, but you this is boring. Like if you do this, it's going to be like 1,000 lines just to do object, and it's boring. So you can do this in a better way, which is doing this. So you want to say this dot name equals, then you want to say some function properties thingy, right? So the color, and we're not going to do number of legs because you know birds will always have two legs unless they're weird birds or have like they don't have one leg, I guess. You could also make a number of legs if you want, but you know the example doesn't say you need to. So, and it also says it needs to be set to 4. So we're going to do this dot color and this dot num legs. This is always going to be 4, so we don't need that. But this will be equal to color and this will be equal to name. So this works, and now terrier should be created using the Docker constructor, right? So now we're going to make let terrier, right, equals new dog. Does this work, or do you also have to input? Okay, so this works. What if you do a console.log terrier dot name? So it's undefined. So let's see, how do you do this? Let cardinal new Bruce red. Okay, so if you also want to, obviously you probably want to give it a name, right? So we'll do this like bull, right? This is the name, and the color of it will be red. So now, as you can see, when I do this console log, it will also upload it will also change the name to bull, and if we do like color, it will be red. But if we didn't have this in here, and this still works, it doesn't give you errors, but it will just say undefined, right? It won't give you errors if you do this. So let's just go. Alright, now we're going to verify an object's constructor with instance of. So instance of is something, I guess, I don't know. I haven't done this object oriented thing yet, so I'm also learning something new. So anytime a constructor function creates a new object, this I'm saying it's a gameplay, it's a fresh gameplay. The object is set to be an instance of constructor. JavaScript gives a convenient way to verify this with the instance of operator. Instance also allows you to compare an object to a constructor. Okay, so they should, yeah, it's true. That's are we still recording? Yeah. So in this example, they have this little bird in here, and then they just made like a crow, which is obviously a bird, and they now tested the crow to be an instance of bird. So now they're kind of verifying, like, are you using that prefab, are you not? In here it will return false, because as you can see, canary instance of bird, you know, you never made a bird, you just have like this little canary, but there isn't an instance, there is a bird, and this is just like an object. It's a little weird, but yeah, basically this won't work, this works. So now we need to make this thing, right? So create an instance of the house construct only with my house and passing a number of bedrooms, then use the instance of verifies an instance of house. Alright, so what we need to do is we need to create a house. Does it? Alright, so we need to call it my house, and then do a new house, and let's just pass in like 4. I think this should work. Oh, I just said horse. New house. Nice. And now we need to verify it. So how you verify is we are going to do my house instance of not bird but house. There we go. And let's see if this works, and it works. How do you do it? Make it return that. Well, I'm not entirely sure you do that. Wait, can I do like a console.log on this? Is it possible even? I don't think it is, but you can always try. Yeah, okay. Ah, yeah, oh, it worked too. Right. So as you can see, it returned true. But if we do like well, it's not defined. But if we delete this thing, or we just comment it and we make it real, my house is not defined yet. So it basically it won't work. So we need to make this, and now it's true. Right. So this is just the way you can verify this. To be more clear about it, you just verify if this is actually a prefab, like, or a constructor of this. You know, it's not that hard. Alright, so let me drink a bit of water. Right. In the following example, the bird constructor defines two properties: name and number of legs. So we have a bird, and we now have two, how is it called, two objects, right? So they both use this constructor and make birds out of it. So these are properties, yes, that means and each of these have like a separate copy of these properties, because this is duck is Donald and canary is Tweety, because why not. So in every instance of bird we have our own copy. So the following code, that's all of adds all of the own properties of duck to the array of own props. So let me see, what does this do? So we have this array in here, and for every property in duck, if the duck has its own property, it will push that property to the own props array. Okay, well, I guess we can try doing this now. So we need to change the thing below this line. We only have one, we only have the canary in here. So we should solve this challenge without using the built-in method object.keys, okay. And you should solve this challenge without hard to okay, yeah, that makes sense. And option should include the values numlex and name. Alright, so we are going to do a for let proper, no, you need a alright, for let name in canary, right? We are going to do this. Also, after that, we're going to do if duck has a canary, of course, has own property name, then we are going to own props dot push name. Alright, so let's see. So canary that has on, okay, I wrote this wrong, of course, property. Alright, and this worked. Let's do a console.log though to see how it works. Own props, and yes, it's returned num name and num flags. Okay, so this displays what it should display. Very nice, very cool. Use prototype properties to reduce duplicate code. So you don't really like duplicate code because it looks ugly, it's hard to maintain, and it takes a lot of lines, so you want look cool online, you know. So since numlex will provide the same value for instance of bird, you know, as I said, like you don't really change the number of flags, right? This may not be an issue when there are only 2 instances, but imagine there are millions. Yeah, so that would be a lot of duplicated variables. A better way is to use the proper type of bird. Properties in the prototype are shared among all instances of bird. Here's how to add numlex to the bird prototype. Okay. Now all instances of bird have the name numlex property. Okay, interesting. So we got this little beagle named Snoop Dog. And now we want, instead of putting this in like the constructor or like the free pub, we just make the prototype, right? So we'll do dog dot prototype dot number of flags equals 4, right? And of course this should already work, yes. But we also, I guess, want to check this. So we'll do a console dot log beagle dot num of flags, and as you can see it says 4. Even if we didn't put it in the constructor, or you know, as I call it, prefab, or and we didn't put it anywhere, if we make a new dog, we're not going to name this beagle, we're going to name this I don't know, golden, and we are going to call it something else like rock, right? Now if we do the console that log of golden that num legs, you'll see that it's also 4, and you know, the name is still different. Like if I do name, it's gonna be rock. So very cool. Let's go to the next challenge. Iterate all over overall properties. Alright, so now we have two kinds of properties, our own properties and prototype. So there are two kinds, for now at least. And we have the one that is in the constructor, right? So if I did like this, that num of legs equals 4, you know, if I did this in here, or the other one, which is the prototype. Alright, nice. Alright, and prototype, yeah. So we have this example in here. Here's how you add duck's own properties to the array own props and prototype properties to add prototype props. So we display name in the console, we display num legs. Alright, so we only change the code below here. And how is the dog called? It's called Beagle. Right. We'll do for let num, you know, what do we want to say? The show own props and prototype properties to array and property dog own property. Okay. Proper. Alright, in Beagle we are going to change that. So we're gonna do this if Beagle that has own property, we are going to own props that push property, and we are going to put this in here. Else we are going to do prototype props that push that property proper. Alright, so now we want to change all of this. So if people for only push the home props array should only contain name. Alright, so in here we want to push the name. Right, and push num of legs. Name, and if not, we want to push num legs. So let's see, how do we do this? Alright, so we have the dogs on property array of props and prototype, right? Name, prototype legs. So I have it here. For well, this is interesting. I'll pause the video for a second. I'll think a bit about this one. Alright, so I realized what the problem was. I was calling the beagle instead of the dog. So if you're still watching, I think everyone was like yelling that at me. Alright, very cool. Let's run the text. Let's go to the next one. I hope the recording is still on. Yep. Okay, so there is a special constructor property located on the object instances duck and beagle that were created in the previous challenges. Okay, so that property is duck equals new bird and beagle equals new dog. Okay, interesting. And this would display true, and you know, so this is how you display that. So if it was if you would comment this out, it would return false. The property okay. Property can be overwritten, which will be covered in the next two challenges. Generally better to use instance of method to check the type of an object. Okay, so we need to join the dog fraternity, right? So if the candidate dot constructor equals dog, right? Then we are going to return true, like it will return the dog fraternity. Else it will return false because you are a spy, right? You're a duck or something. Yeah, there we go. So if we had an object like um, like a bird, this would fail because it wouldn't work. So let's go. Alright, now we are going to change the prototype to a new object. So up until now you have been adding properties to the prototype individually. So okay, bird.prototype numlegs equals 2. Okay, yes, we have been adding prototypes individually, yes. This becomes tedious after more than a few properties. It equals function, num, prototype describe, my name is. A more efficient way to set a prototype to a new object that already contains the properties. This way the properties are added at once. Okay, so basically, this is interesting. If you don't want to put them in here, you can make like a property construct. It's not really a constructor, but it's. And then you can put them in here. I guess it's better. I don't really know. Let's just go for it. Alright, so numlegs. Let's have some nice, right? We're going to say 4. And we're gonna make some functions. Um, we want to make the eat function. So eat. Alright, should be a function. Not very difficult. Let's go. And we are going to do a little nom. Right, and I typed delt very well. And then we're going to do another function which is going to be the describe one, in which you are going to very nicely describe yourself and say console.log. My name is Anton. My name is plus his name. Alright, which is going to take the name from here. You can say dog in here as well if you want. Yeah, let's not forget these if they're not that important. And there we are 50% done. Very nice. Remember to set a constructor property when changing the prototype. There is one crucial side effect of manually setting the prototype to a new object. It erases the constructor property. Oh, so this is very sad. Now it gives false results. So this is interesting. To fix this, when we apply the new object, we want to define the constructor property. So in the thing we did before, we kinda overwritten this, I assume. So if we set like something that is in here, we just delete it, right? So what we do is we say constructor to be the dog. So now we cannot really just mess it up, I guess. Alright, fair enough. Let me just check how many exercises do I have left. Nothing here in JavaScript. Right, so we don't have that many left. We have 12 more. Right, so just like people letting have genes from their parents and protein parents are created. For example, here's the bird constructor creates a duck object. Okay, yeah, we know that. Duck inherits its prototype from the bird constructor function. You can show this relationship with the isPrototype of method. This would return true. Okay. Well, I guess I'll check it. So dog.prototype is prototype of beagle. Okay, and this should return true. Very cool. Alright, nice. Let's go. All objects in JavaScript, with a few exceptions, have a prototype. Okay, some interesting exceptions. And source on objects prototype itself is an object. Okay, objects. Because prototype is an object, a prototype can also have its own prototype. In this case, the prototype of what prototype is object that prototype. So now you can have a lot of prototypes. Why? Because you can, and that's the fun of it. Alright, we got a little question marks in here. So, how is this useful? Good question. You may recall the has-on property method from the previous challenge. Okay. Your code to show that object.prototype is a prototype of dog.prototype. I see. Okay. So, in here we are going to say beagle. Wait, your code to show that object.prototype is a prototype of dog.prototype. Okay. So, okay, just do this. Show the prototype. Alright, so what object? Okay, type of bird.prototype. This name, let beagle new dogs. Newbie. So dog.prototype is prototype of beagle. So prototype is prototype of dog.prototype. Okay, so beagle, if we just do this, that this is our prototype chain, and bird is a super type for dog. Objects are both adopt, therefore we can use the has on property. Wait, so do it just has own property? Object that prototype is prototype of bird that prototype. Okay, let's go with this, but we just do dog. There we go. So we needed to say that it's also prototype. Yeah, okay. So basically what we did wrong is we forgot to also say it's a prototype because it's a object that's also a prototype. Very nice, very nice. Okay, use inheritance so you don't repeat yourself. There's a principle in programming called don't repeat yourself dry. There is a repeated code is a problem because any changes require fixing in code in multiple places. This should mean more work for progress or more room for errors. Alright, so basically you wanna work smart, not hard. Notice in the example below that the describe method is shared by bird and dog. Okay, so the describe method both have literally the same thing, right? So this is cringe, right? Because you have it in the same place. So what you could do to follow the dry principle is to create a super type or a parent, you know, which is going to be the function of animal, and then you can just say constructor bird. So now you use the constructor in here in the changes and it's bird. So very nice. So you have all of these things in here. Function bear. What is this one? Okay, so this you don't need this, you just want to do it in here, I guess. And then you just want to delete this from here and here. Alright, and there you go. So you might ask what I did. All of this use the animal prototype, right? This is the function animal. We should probably just put this up in here. Yeah, I think it just looks cleaner if it's up in here, I think, and it should still work. Yeah. So what you are doing over here is that you are okay. You are making this prototype for all the animals to use, right? So you're going to have the constructor cat, and they will all have the eat function, which is very cool. So if you do like that, it works. Alright, you should go to the next challenge. Right, in the previous challenge you created a super type called animal that defined behavior shell by animals. Okay, yeah, makes sense. This and the next challenge will cover how to reuse the methods of animal inside bird and dog without defining them again. It uses a technique called inheritance. This challenge covers the first step. Make an instance of the super type or parent. You already want to use a new operator. Okay, yeah. So there are some disadvantages, which is too complex. Instead, let's use right without those advantages. Okay, basically this is just the cooler Daniel. This is Daniel. This is the cooler Daniel. Um, so we have this super type in here, and how we should make it actually so that it's good is to the duck variable should be defined. Use object that create to make two instances of a name named duck and beagle. So we want to object that create that stuff. So let duck will be equal to object dot create, right? And we'll do animal dot prototype. There we go. And then we can just copy this same syntax, put an equal and paste it. Okay, so this will just get everything from here. It will take it from here. Let's see if it works. Yes, it will just 69% completed. Very nice. It will take everything from here and it will put them over here. It will basically take it, steal it like a Romanian. Alright, let's go to the next challenge. So set the child's prototype to an inherit of the parent. So we are working with more objects. Very cool. So you set the first step for your behavior from the super type animal, making a new instance of animal. So this challenge covers the next step. Set the prototype the child, or the subtype, whatever you want to say it. In this case, birds to be an instance of animal. Okay, so yeah, makes sense. Remember, the prototype is like the recipe for creating an object. In a way, the recipe for burnout includes all the key ingredients from animal. Okay. So now duck inherits all of animal's properties, including the eat method. Modify the code so that it is inherited from animal. Okay. So how we want to do is modify the code so that instances of dog this are going to be using the include the eat method, so the one from the animal property. So you want to only change the code below this line. So instead of doing the new dog, right, we want to do like object not create. Right. Oh, it needs to be dog. Okay, okay. So we need to do a dog prototype. But dog.prototype should also be an instance of animal. So how we do this is that we say that this thing will just kind of steal it, and we'll say that dog.prototype equals this. Very nice. Now it works just fine. And yeah, we can do like beagle.eat now, right? Not forget this though. Nom nom nom. And it works very nice. Okay. When an object inherits a prototype from our object, it also inherits a supertype constructor property. So here is sample. Are we still recording? Yes, 40 minutes. Very nice. Best video. Alright. Function bird.prototype object create animal prototype. Let duck equals new bird duck constructor. Okay. But duck and all instances of a bird should show they were constructed by bird and not animal. To do so, you can manually set the constructor property of bird to the bird object. Oh my god. Fix the codes of duck constructor and beagle constructor and turn their respective constructors. Nice. So basically we need to do some weird stuff in here. We need to make it Wait. So we need to change this a bit. So bird is, you know, an instance of animal and dog, but beagle.constructor does not return dog. It returns something else, which is not cool. So we can just check real quick what it returns. We'll do a constructor, and it returns animal instead of bird. So that is a bit of a problem. So what we want to do, but was started by bird and not animal. So to do so, you can manually set the constructor property of bird to the bird object. So bird.prototype constructor equals bird, and I think that's exactly what you have to do. And we can also do this one for dog, right? So if we do this, now it says very nicely that it's a bird indeed. Oh, that's not on the dog. Oh, because of course it says bird indeed. There we go. So now this is just to change the constructor, because right now it would say animal because it just takes everything from animal, right? It takes all of it, but now it no longer does. So very nice. 77% completed. We are almost done. So we can also check how many we have. I think we don't have many left. So if you are curious how many we have left, we got 6 left, which is very good. Okay. Add methods after inheritance. A constructor function that inherits its prototype object from a supertype constructor function can still have its own method in addition to inherited object. For example, bird is a constructor that inherits its prototype from animal. Okay. So function animal. Okay, animal prototype. Alright, let's see what's completed. Okay. So I don't necessarily dog, so dog is inherit from animal, the dog's prototype constructor is set to dog, then add a bark method to the dog just, so the beagle can both eat, bark, the bark method should print woof to the console. Okay. So to change everything in here. So dog should inherit the eat method from animal. Okay. Function dog. Alright, so I think first off we need to create this. So we do dog. Right. Yeah, so that fixed a bunch of things. The dog prototype should have a bark method. Okay. And the constructor beagle should be set to dog. New dog. Okay. So next up we want to do dog.prototype.constructor equals dog, right? We also got to do this. And now we need to edit a new thing to it. So we'll do dog.prototype.bark is going to be a function, right? A function, I'll queue the function. And we'll do console.log, right? And we'll do woof. Okay. There we go. All dog. And now, awesome. So basically what we did in here is we have this the function animal, right? Where our parent or super type, whatever, is as this little function called eat in it, right? And the dog, of course, it's going to use it. It's going to steal it from it, right? It's it's getting it from the parent, but it's a different, it's an animal. It's not like a parent, and it also can bark. So we added this in here, and we made it so the dog is actually a dog, not an animal. Right? They separated. They kind of had an argument. They separated. So now this is a dog, and they also added the wolf, but it still has some of that remaining, so it can still eat. That's kind of example. Very nice. 81% completed. Alright. So let's see what it works. Penguin flash return. Alas, this is a flightless bird. Okay. So now we have this. What you need to do is in here we have a bird, right? But you know, penguins are also birds, but they cannot fly, so they cannot just say, "I am flying," right? This does not work. It's not okay. It's not fair for them. So you learn can hear it from right? So this can reference it. Here is a chaining element is prototype. But it's also possible to overwrite an inherited model. It's done the same way by adding a method the child uses the mod same names the one to overwrite. Here's an example of bird. Right, I see. So basically in here we are going to, we don't really like birds anymore, so we are just going to overwrite it. So penguin that prototype that fly, sorry, equals function. Oops, there we go. And we are just going to return alas, it's a flightless bird. I'm just going to copy this. Boom. Yeah, okay. So this should work. Very nice. And if we didn't do this, how did you do this in JavaScript again? This? Yeah, right? And it would just say I am flying, which is not okay, penguins can fly. They can't. It's impossible. So we did this. Very cool. Very nice. So now we are going to use this thing called mixin to add common behavior between unrelated objects. So they are not really same family in here, but they have some similar things, I guess. So inheritance does not work well for unrelated objects like bird and airplane, but they can both fly. But a bird is not a type of airplane, and vice versa. So they are related in some way, like an airplane. They kind of try to copy birds, but they're not really birds yet. They didn't pass the test, so they're different, but they have some similar things. So we are going to do this thing called mixins, and the mixin allows other objects to use a collection of functions. Okay. So to change it below. So the fly mixin takes an object and gives it the fly method. So in here we have like let bird, tunnel, there's the legs, and we also have this plane, which it's a model and it's 7077, and there's the number of passengers 524, and they are both passed in fly mixin, which then assigns the fly function to each object, because we did this function right in here. Now bird and plane can both fly. Very nice. So that goes to solve the display the same for each fly call. Now the missile has fly. Alright. So now we're going to glide. A bird and a both can they can glide. So we are going to do this. So let's quickly make a function. We are going to say that let glide mixin equals function for an object, and then we are going to do the object that fly. It means that's a function, and what this will return, what they want me to return, doesn't say. Then use the glide, give both. I guess you can just say whatever you want. Console.log gliden vroom. Okay. So we did this, and now we should declare a gliding function. Very nice. And now we want to do something in common, so we're going to do glide mixin with for the bird, and the glide mixin for the boat. Does this work? No. Very nice. So let's see what doesn't work. Fly mixin, bird and plane can both fly. Give it a glide method. Okay, so what happens with the bird that fly? Gliding, room, plane that fly. Gliding, plane is not defined. Oh, I meant boats that fly. There we go. Alright, wait, what? So why doesn't it work? Uh, okay. So then use the glide to give buff the ability to glide. Oh shit. Okay. Board, yeah, it should be glide, not fly. Okay. Missing semicolon. Yeah. I really hate when they do that. There we go. So yeah, I forgot. I copied this wrong. It's not fly, it's glide. Yeah. You know, because I made it fly everywhere, it worked, but Freecodecamp kinda hard codes the things. So yeah. We use closure to protect property with an object from being modified external. So this is something that you probably want. You know, you don't always want to be able to change it, right? Like maybe you're gonna have birds, but you're not gonna have penguins or something. I don't know. But point is, you don't not always want this. Maybe they weigh the same. So let's do this. Add a property name. It is considered public because it can be accessed and shared outside of birds definition. So different birds, different names. Makes sense. But therefore, any part can easily change the name of bird to any value. And um, think about things like passwords and bank accounts being easily changeable by any part of your code base. That would be pretty dangerous, right? You don't really want to change it. So the simplest way to make this public private is by creating a variable within the constructor function. The is composed variable to be within the constructor version versus globally. So we'll just make it a let. Alright, this way the variable can only be accessed. Right, so we need to do a let weight equals 15. So if did this. Now your code should create a method in the bird called getWeight that returns the value of the private variable weight. Okay. So we are going to do this dot get oops this dot get weight equals new bird, right? Oh, not what am I doing? Not new bird equals function. Right, function, we are going to want to return weight. So now it should also become, yeah, very good, very nice. So now it returns this. We can also go further. Let's say let, we can just copy that example, I guess. New bird, boom, and now we just do like a ducky that get weight. Yeah, you wanna do this in a semicolon. There we go. So it's 15, which means we kind of hard coded this. So now I don't think you can actually make it, change that thingy. So very nice. A common pattern in JavaScript is to execute a function as soon as it's declared. This is another function that expression executes right away and outputs chirp chirp immediately. Note that the function has no name and it's not stored in a variable. The two parents and a function expression causes to be immediately executed or invoked. Right, 54 minutes. This pattern is known as an immediately invoked function expression, or EEFE. Rewrite the function make nest and remove its call. So instead it's anonymous immediately invoked function expression EEFE. Okay. So we need to make this function be secret, really secret. Secret. Right, and we don't need this anymore. Easy. Wait, what? Right, so this is not anonymous. I remove its call since anonymous invoked. Well, why isn't it anonymous? It's oh, I get it. We don't need this. And now it's very secret because you are never. This is like immediately executes this. Like you'll never do this again, right? So you don't need to call it. Just do it right on the spot, right? You're not gonna call it later. So it's just like void. Okay. Use an INF to create a module. Nice, so now we're creating a module. So what does this want? We can group these things in a fun module should be what? What the hell? Why did that what? Uh okay. Well, I don't know why that worked. Okay, weird. Well, I'll just do it now, I guess. So that okay, whatever. Does it work anymore? No. Okay, weird. Wait. So what does it want? We need to make a module. Uh-huh. Very nice. Wait, that's it. So we need to create a module. So we're going to do let um, fun module. It's a really funny module. Right, and we're going to make this a function. And return. I'm just gonna delete this for now. Let execute mixing. We don't need this, and we don't need the let. Of course, let's also do this for here. Oops. We don't need this, and we also don't need that equal. I'll just copy this thing down here. It's probably fine. And then here we need this. Right, and that's it. So we created a module, and as you can see, it's 100% completed. Let's go. So now it's something else, and it's functional programming. And there we go. We did the object-oriented programming course. I hope you enjoyed this epic gameplay. You probably didn't watch it all because why would you? I hope you enjoyed it if you watched it, and I'll see you in the next one. Bye.